When you hear about containers, you'll often hear the word Docker thrown into the mix. You might hear phrases like Docker container, you might recognize the company called Docker, and you might hear Docker referred to as a tool set for working with containers. These are all appropriate uses of the term Docker, but there are obviously a lot of different meanings out there. Let's begin this video by describing what each use of these terms means. Docker is a software platform for building and running applications as containers. Although containerization technology existed long before Docker emerged on the scene, Docker has become inextricably linked to containers. This is because the launch of the Docker open source project in 2013 fueled the rapid growth in popularity of containers and the various technologies and practices that accompany them. Docker provided a straightforward way to build and run containers through an open source platform. This led to an explosion of not only Docker and containerization, but also a myriad of complementary tools, technologies, and development methodologies that still prevail and continue to grow. A Docker image is simply an image that was built using Docker technologies. People often tack the word Docker onto container and image and use Docker image and image interchangeably. Given the growing ecosystem of container tools, we'll use the simpler and more general terms container and image throughout this course. The open source Docker community develops these technologies for the benefit of its users. Docker, the company, builds on the existing open source technologies, contributes back to the community, and provides technologies for enterprise customers. One of the most used tools from Docker is the Command Line Interface, or CLI. This tool is used extensively in modern software development, and it will also be used in a variety of ways throughout this course. In the course labs, you will have the opportunity to use several Docker commands. Let's briefly discuss a few of the most common Docker CLI commands. Given appropriate input, the Docker build command is used to create container images. Developers provide a Docker file, a file that serves as a blueprint for building a container image. The Docker build command takes that file and performs the heavy lifting to build an image. The command also enables users to tag their images, which basically means giving them a name. You can directly tag images using the Docker tag command. If you have an existing image that you want to rename, for example, if you received the image from someone else, or if you want to store it in another location, you can use the tag command to, in effect, copy the image and give the copy a new name. The tag command won't overwrite the existing image that you have on your machine. It will create a new tag that points to that image. The images command will list all the images, their repositories and tags, and their sizes. Once you build or tag an image, there should be an updated entry in the Docker images output. This provides a simple way to check that your build and tag commands executed successfully. As the name indicates, the Docker run command is used to run a container. If you are developing container images and you want to test an image that you have deployed, you can run it as a container locally. The Docker run command is perfectly suited for this task. Finally, we have the push and pull commands. We'll discuss these commands in more detail in our video on container registries, but for now, you simply need to know that these commands are used for storing images in a remote location and then retrieving those images. Remember, we'll get to use all these commands in our labs throughout the course. Docker is also a container runtime. A container runtime is software that executes containers, much like the Docker run command that we just referenced. Let's see how the container runtime fits into a typical stack. As we've discussed, we first have the hardware or infrastructure as the bottom layer. This is the physical machine or machines on which our software will run. On top of that, we have the operating system. Remember that we said containers share the operating system rather than just the hardware as virtual machines do. With containers, we have both the hardware and the operating system on the bottom of our stack. Next comes the container runtime, like Docker. Again, this is the layer that will run our containers. Finally, on top, we have the applications that we run as containers. Docker is probably the most popular and best-known container runtime, but Docker has also introduced the Containerd runtime, which is quickly gaining popularity. Other runtimes, such as Rocket, are used in the market as well. In this video, you've learned about the many uses of the word Docker and how it applies to the software platform, the company, and the open source community. In addition, you've learned about the Docker CLI and some of the more commonly used commands it provides. Finally, you've learned about the Docker container runtime and its place in the containerization stack. In the next video, you'll learn about building container images with Docker.